So one of the reasons why I love teaching calculus so much is there are every single topic that we teach. Every day when we talk about something new or we do some different notes, we're going to always talk about these problems in 4 different ways. All right, we're going to see every idea that we discuss in 4 concepts. We're going to talk about it numerically. Okay, we'll call that tabular. Okay, a tabular approach, which means a table. It's fancy for table. A table graphically, so we'll look at pictures of it on a graph. We'll look at it algebraically, so like y equals 3x squared plus whatever. And then we'll also look at it conceptually, where basically we're going to combine all of those concepts together, think about some different stuff, use our graphing calculators, and kind of make a 4th category of conceptual. And so by the end of this, you'll have a really deep understanding of all these things because we're going to be able to see it in all these different ways. So our first example here is the easiest one. Use the table and the graph of f of x to determine the limit as x approaches 4. All right, so this is the problem we are doing right here. We are trying to find this. Find the limit as x approaches 4 for this function. So we did this a little bit in bell work. Here is a graph of f of x. We want to know what is the limit as x approaches 4. A reminder that I could not care less what is happening at 4. We don't care what's happening at 4. I care what happens as we approach 4. As I go from the left side and the right side, what number are we getting closer to? And so on this first picture, I always like thinking of a guy. He's right here. I got another guy up here. And these 2 guys are going to walk towards each other. And they're going to get closer and closer to x equals 4. As those 2 guys get closer and closer to x equals 4, are they going to meet each other? Does it look like they're approaching the same thing? Yeah. What number does it look like they're approaching? 11. The limit as x approaches 4 is 11 because as they get closer and closer to each other, they're getting closer and closer to right there, which is 11. That's the limit as x approaches 4. We could look at that as a table as well. This is exactly what we did in bell work. As my x values got closer and closer to 4 here on the left-hand side, and my numbers got closer and closer to 4 as we went from above and closer to 4 this way, I don't know what happened at that number, but it looks like we're getting really close to 11, in which we are. So this is how we state these things. When we look at this thing right here, this is the way we say this is the limit as x approaches c. The limit as x approaches c of the function f of x is equal to a limit. So the problem we just did, the limit as x approaches 4 of my function is 11. The limit is 11. That's just how we read it. It looks like weird notation. That's how we state that. The limit as x approaches blah, blah, blah. So what that means is x gets closer and closer to our number. So as we got closer and closer to 4, our y value got closer and closer to 11. In order, this is important. In order to have a limit, in order for a limit to exist, the function must approach the same value from the left and the right-hand side. Left and right-hand side in order to have a function. So let's look at this graph right here. On your paper, I want you to graph x squared minus 2. Take a second on that box right there and graph x squared minus 2. See what that looks like. So given that graph right there, x squared minus 2, we're going to find some different values. We're going to find the limit as x approaches 1. So show me with your fingers, what do you think the limit is as x approaches 1 for that graph right there? Show me with your fingers. As we get closer and closer to 1, so here's my graph. Here's 1. As I get closer and closer to 1, boom, on this way and this way, I'm getting closer and closer to a y value of negative 1. Guess what happens if you take 1 and you plug it into that equation? 1 squared minus 2, what would that get you? Negative 1. Okay, cool. Limit as x approaches negative 2. So I'm looking at my graph. I'm looking at the limit as x approaches negative 2. Show me with your fingers. What's your y value going to be? As you get closer and closer to 2, my value is 2. And the limit as x approaches 0. So we're getting closer and closer to 0. Show me with your fingers what's your value as you get closer and closer to 0. It's negative 2. Those are all really easy problems. All right. really all we just did with all of those was take those numbers and plug them in. Okay, we could look at it graphically. We can see a limit graphically and algebraically at the same time. Wonderful. Let's do the next part here. So now what we're going to do is we're going to look at a more realistic graph for these types of questions. So they will give you graphs like this. These are very piecewise functions. You've got asymptotes, you got holes, you got open circles, closed circles, all those different things. And based on that information, we're going to describe limits. So for letter A, it says find the limit as x approaches 0. Your graph isn't very good. The students informed me first period. So here's 0 right here. I really don't care what's happening at 0. I'm covering it up. But as you walk from the left-hand side and the right-hand side, what number does it look like we're getting closer to? 1 point something? Maybe 1.5, 1.6. Cool. Let's call it 1.5 just to make our lives easier. It's getting closer to 1.5. Have you said 1.6? My last class said 5/3 because they were just trying to be mean. But sure, if that makes you feel better, call it 5/3. Limit as x approaches 2. Limit as x approaches 2. Look at that graph. See what you think. X approaches 2. -2. Here's 2 right here. If you had one guy walking this way, one guy walking this way, we're getting close to -2. Not too hard. Limit as x approaches 8. We're walking this way. We're walking this way. We've done this enough now. We'll call it 0.5. All of those are pretty easy. We could do those all day long, and you would never miss one, hopefully. Now we get to one that's a little bit tougher. The limit as x approaches 4. You're getting closer and closer to 4 from both sides. So you got a guy walking on this line. You're getting towards 4. Guy walking on this line. You're going towards 4. Show me with your fingers. What do you think the limit is? Are they ever going to meet? The line on the left-hand side, as we go up, we're getting closer and closer to infinity. On the right-hand side, we're getting closer and closer to infinity. And so they're both aiming towards infinity. Is infinity a limit? No. Buzz Lightyear said you can go to infinity and beyond. Okay? It doesn't limit us at all. And so it's not a limit. When we have a question like this where both graphs are going towards infinity, the limit does not exist. The limit does not exist. I know. You've been waiting a long time for someone to say that to you, and now it's real. Every year I get really excited when I get to teach the limit does not exist. Limit as x approaches 1. Look at your graph. Look at 1. Show me with your fingers. What do you think the limit is as x approaches 1? That's not your fingers, Carrington. That's cool. It's now on YouTube forever, and so everyone's going to know that you weren't using your fingers. Show me with your fingers. What's the limit as x approaches 1? The correct answer is I don't know. Right? Let's look at this thing. You're getting closer and closer to 1. A reminder with limits. I do not care what happens at 1. At 1 doesn't matter. You have a dude walking on this line or a dudette. I don't really care. You got a girl walking on this side. They're walking towards each other. They're walking towards 1. When are those two guys going to meet? They're not going to meet. They're not approaching the same value. The left-hand side is getting closer to 1. The right-hand side is getting closer to -1. They are not aiming towards the same number. If they're not approaching the same value, the limit does not exist. They have to be approaching the same number. I don't care what's happening at that spot. A lot of you told me -1. I don't care that it's a closed dot because I don't care what's happening there. I am blocking it out. Okay, on my projector, I always like to hold the yardstick right in front of it. All right, I don't care what's happening there. I care what's happening as you get closer to it. Limit as x approaches 1, and then we've got a new notation, this 1 with this little negative sign. It is not -1. It is a 1 and then with a negative sign. That notation means a limit from the negative values, or in other words, a limit from the left-hand side. Okay, this is a left-sided limit. Or in other words, all you care about this time is approaching 1, but I'm only having the person walk from the left-hand side. So again, you're aiming towards this line. You're going to 1. As you walk on this line, what value is that person getting closer to as you approach from the left-hand side? 1. That person is getting closer and closer to 1. I've got a limit with a 1 and then a plus sign on the top right up in the exponent spot. What do you think the plus sign means? We are approaching that value, but we only care from the right side. So if we're approaching that thing from the right side, you're walking that line, you're getting closer and closer to 1 from the right side. What number are we getting closer and closer to? -1. It is a one-sided limit. Questions on the front on that first set of numbers? Flip it over. So we can have one-sided limits. If there's not a plus or a minus sign, we're assuming it's both sides. In order for a limit to exist, both sides have to be equal to each other, but you can look at it from just a left-handed or a right-handed approach. What I want you to do with your neighbor here for a second is go through A through E, looking at that graph, and try to identify your limits. See what you can do. All right, here we go. Limit as x approaches 2. Grant, what do you say for limit as x approaches 2? 0. But there's the closed circles down here. Okay. It's math. Yeah, it doesn't matter. We care about right here. He's covering that spot up. He doesn't care about what's happening there. If you cover that up, oh, I froze my screen. If you cover that up, it looks like it's going to 0. So that's what our limit is. If that's what it looks like it's going towards, that's what we care about. What about the next one here? Limit as x approaches 1 from the right side. Drew, what do you think on that one? -2. We're looking at 1. We're going from the right side, so we're only going this guy. It's -2. Good. Limit as x approaches -3. Kate, what'd you say is the limit as x approaches -3? But there's an open circle. Doesn't matter. We cover that up. We don't care what's actually happening at 3. As she walks from the left and the right-hand side, we're getting closer and closer to 3. That's what I care about. Limit as x approaches -1. Audrey, what do you think about limit as x approaches -1? Does not why does it not exist? Each side, if she approaches -1 from both sides, you're going towards way different numbers. Again, if you covered up -1, you put your pencil over top of it, those two lines are not going to the same thing. So if they're not going to the same thing, the limit does not exist. Wonderful. Let's go to the next one, and it looks tougher. If I would have given you these questions to start the day, you would have had no problem. Don't let it be weird. Not a limit. It's just f of 2. What's the difference if I just ask you f of 2? Your actual value. In this guy, we're not walking on the lines anymore. F of 2 means, show me with your fingers, what do you think f of 2 is? F of 2, I always think of like a parachuter, okay? If you went to 2, you got this guy. He is parachuting straight down on 2. And so as he parachutes down on 2, he's going to keep going until he hits a closed dot. And when he lands on that closed dot, that's what f of 2 is. So f of 2 in this case is -3. Show me with your fingers, what do you think f of -1 is? F of -1 is -3 because we're starting right here. And kersplat, right there at -3. We keep going until we get to the closed circle. Show me with your fingers. What is f of -3? When is that parachuter going to hit the ground? That's a rough day. He's never hitting the ground. It's D&E. The one time you actually want to hit the ground? That sounds bad. Questions on something there with limits? You will understand them, and then we'll do something different, and all of a sudden you'll get a little bit murky on it. Keep practicing these things, and we will do that a lot here in the next few days. On the bottom part, we are now going to talk about limits with a table. We did this in Bell Work. We're going to show you how to do this with your graphing calculator. So take your graphing calculator and pull that out for me. So we're in our graphing calculator. We are going to look at this first one. The problem we were doing first was the limit as x approaches 3 of 5x squared. Anybody have a guess as to what the limit as x approaches 3 of 5x squared is going to be? The answer is 45. Hannah, how'd you get 45? Yeah, plugged 3 in for x. It gave her 45. The answer is 45. Let's show us how to do this graphically. This is the easiest one. You don't need a calculator for that. You can do that in your brain. 3 squared is 9 times 5 is 45. Let's show it to you graphically, and then we'll do some more difficult problems. So in the y1 screen, so I hit y equals. In the y1 screen, I'm going to type in 5x squared. If you're in parametric mode, you got to change your calculator back to regular. 5x squared. The next thing we're going to do is we're going to go to table set. And so we haven't done this. Once you've done it once, you don't have to keep doing it. But I'm going to hit second and table set, which is right here. So second and table set, which is that button. All right, what you need to do is you need to go down to the independent variable and turn it to ask. Right now it's automatic, and we don't want it to be automatic. We want to tell it what to look at. And so we go down to independent, and we go to ask. Everybody good with that? Now we're going to go to the table. So we're going to hit second, and then the graph button up there in the top right-hand corner. It says table. We're going to look at a table. Sorry, I was trying to clear that out. There we go, whatever. Oh, no, I didn't want to do that. Sorry, I accidentally deleted my equation. Second table. Okay, cool. What we want to do is we want to find numbers that get closer and closer to 3. We're trying to find the limit of this number as x approaches 3. In order to do that, I need to look at numbers on the left-hand side and the right-hand side of 3. What is a number to the left-hand side of 3? 2. Would you agree that 2 is on the left side of 3? So let's type in 2. And when you hit enter, it'll give you a number. My number was 20. I need another number on the left-hand side of 3, but let's get closer to 3. So what's a number that's a little bit closer to 3 than 2? 2.5. And like 2.9. And 2.999. And 2.99999. And it'll round it to 3 for me. Or we could just type in 3. Oh, cool. 3 was 45. We kind of knew that, but good. We got that. What's a number I want? That's the left-hand side. I want to check the right-hand side as well. What's a number a little bit bigger than 3? 3.001. And 3.01. And 3.1. And 3.5. And so on. We could type in some numbers, but we've got our table. In order for it to be a limit, the left-hand side and the right-hand side need to be approaching the same value. As you get closer to 3 from the left-hand side, as you get closer to 3 from the right-hand side, are you approaching the same value? What are we getting closer to? 45. My answer is 45. Done. Makes sense on the first one. Let's look at the next one. X squared minus 4 over x minus 2. X squared minus 4 over x minus 2. The last one, Hannah said we could just plug a number in. Plug in 2 real quick. You don't need a calculator to plug in 2. Let's just plug in 2. 2 squared minus 4 over 2 minus 2. What happens when you plug in 2? You don't get 0. You don't get undefined. Let's talk about that real quick. What does 0 look like? When we talk about 0 as a fraction, what is 0 as a fraction? 0 over some number. In order for you to get 0, it's got to be 0 over a number. What does undefined look like as a fraction? Some number divided by 0. That's undefined. This is a third type of numbers. This is not 0. This is not undefined. What we just got here was 0 over 0. That is called indeterminate form. Okay, that's going to become really important in limits. Indeterminate form. That basically means I don't know what the answer is. What is happening on this graph? Think back to your polynomial chapter. What is happening on this graph? Why are we getting 0 over 0? Say it again. It's a hole. There is a hole in my graph at 2. At x equals 2, there's a hole. That is why we're not getting a value. And so just straight plugging this in doesn't work, but a table will. Let's go to our graph. Hit the y equals button. Let's type this in. So we've got x. I'm going to put it in parentheses. Parentheses x squared minus 4 divided by x minus 4. You could type it in, or I'm sorry, x minus 2 in parentheses. You could type it in using the fraction button as well, like we did the other day. That would make this easier considering I can't type x minus 2. Looking at the table, second table, I want to find the limit as x approaches 2. So what number should I plug in on the left-hand side? 1.9. 1.99. 1.999. Then I'm going to type in 2. In my calculator, what happens when you plug in 2? There's an error. That you had 0 over 0. That was indeterminate form. So if you would have just plugged in 2, it doesn't help us at all. But I plugged in 1.9992. Let's go 2.001. 2.01. 2.1. Oh, cool. What number on the left-hand side and the right-hand side, as we got closer and closer to 2, what number did I get? 4. 3.99, 4.001. I'm going to assume that the limit is 4, and it is. Questions on B? I'm going to change C because I don't like C. Let's do this. Let's do the limit as x approaches 0. And let's make f of x equal to absolute value of x over x. Absolute value of x over x. Find the limit as x approaches 0. Do that in your calculator. To do absolute value in your calculator, the best way to do that is you go alpha F2. If you hit alpha F2, you've got the ABS button. You can click on that right there. It's also in your math menu. If you hit math and go over to NUM, ABS is right there as well. I like to go alpha F2, though, because it's just as easy. Absolute value of x all over x. Second table. You're trying to find the number. You're trying to find the number as x approaches, what are we approaching? 0. See if you can do that. So I would be like negative 0.1, negative 0.01, negative 0.0001, and I'd want to plug in 0, plug in 1, or I'm sorry, 0.001. Just plugging in numbers all around. What do we think here? Show me with your fingers, what do you think the limit is of this guy? We'll do this. If the limit does not exist, throw up the X sign. The limit does not exist. Why does this limit not exist? Different numbers. One side you're at -1, one side you're at 1. This is a graph you need to know. Hit the graph button really quick on your calculator. You get that picture right there. That is one that'll pop up all the time. That limit does not exist.